Well, we are starting today with petrology. Okay. MPSC has given us the syllabus of petrology in several parts. That this official syllabus. Okay. Official syllabus says that these petrology portion is sedimentary, igneous, and metamorphic. Right. In these basic petrologies, they have given the classification. Right. They have just asked for the basic classification and some of the parameters which are related to the hydrogeology. Okay, just like in sedimentary, they have asked for porosity of the grains, then water bearing capacities of the sedimentary rocks. Okay, and in igneous rocks, they have majoritarily focused on basalts, right? In the Deccan basalts, just okay. I'm sorry for the interruption. I just had a call. Okay. Okay, what I was discussing. Yes, the syllabus. Right. So they have given us the basic classification, and in igneous rocks, they have majoritarily focused on basalts, on the Deccan traps. Right. Whatever the Deccan traps are, what is the lithology of the Deccan trap, what is the flow mapping, how what is red bowl, green bowl, what are the aquifer properties which are given in these Deccan trap areas. Okay, all these things. Right. So we will be starting with igneous rocks today. Okay. We'll be dealing with igneous rocks. What are igneous rocks and their classifications? Okay. I'll restrict my class today for igneous rocks only. Right. Igneous rocks and their classification. Today's topic will be igneous rocks and their classification. And from tomorrow and tomorrow's class, we'll move further. Right. So the classification of igneous rocks. Okay. Is the screen visible to you?
Yes, sir.
Yes.
Okay. So the igneous rocks. Okay. Igneous rocks are classified on the basis of their composition, okay, and textures. Okay, the igneous rocks are classified according to their composition and the textures. Now, what is this term composition means? composition is determined by the magma chemistry. Okay, all of you know about the composition of the igneous rocks, how the igneous rocks are formed. Okay. So, igneous rocks, their formation, right? Just a minute. Am I visible? My video is visible to you, right? Correctly? Or it is stuck?
Visible.
Is my video visible or I'm stuck on the screen?
Sir, your video is stuck, but your audio is clear.
Okay, that's just a minute. Correct this. Okay, now
Now, sir, fine.
Clear.
right? Okay. Just let me know if such blunders happen, right? So that I can correct it. Okay. Okay. So composition of the igneous rocks is determined by the magma chemistry. Basically, igneous rocks are the primary rocks, right? Igneous rocks are the primary rocks. Primary rocks means which are formed directly from the magma. Okay, so this chemistry of the magma, right? This chemistry of the magma will be reflected into into the rock itself, right? Just like whatever you are eating, right? Whatever you are eating, you will reflect like that. If you are eating like non-veg on daily basis, okay, so you'll be masculine, you'll be massive, you'll be rich in proteins. Okay, if you are having only vegetarian, okay, so that uh, uh, your things will be, or you will look something different, right? Should be okay. So whatever the composition of the magma is, okay, whatever the composition or whatever the chemistry of the magma is reflected, right? This chemistry is reflected into the rock itself, okay, into the rock itself. If the magma is silicic, if the magma is acidic, if the magma is basic, if the magma is intermediate, whatever the magma is, whatever the type of magma is, it will be reflected in the composition of the igneous rocks, right? So this is one parameter of classification of igneous rock. Another parameter of classification is its texture, right? And this is one of the most important parameters for the classification of igneous rocks. Okay. Now, what is this texture is all about? Size, shape, arrangement, and degree of crystallinity of rocks constituents. Okay, all these, okay, all these collectively form, okay, all these collectively form the texture of igneous rock. Okay. All these collectively form the textures of igneous rocks. Now, majority of the rocks, okay, majority of the magmas, majority of the rocks, whatever the rocks you know, all these rocks or majority of these rocks, they are silicates, right? The silicate magmas. So the magma themselves, okay, the magma themselves are silicate magmas. Okay, what does it mean, silicate magma? Silicate magma means which is rich in silicon and oxygen. Okay, with silicon and oxygen in mineralogy. Okay, in your mineralogy classes, not here obviously, okay, in your mineralogy classes you might have come across this term silicate structures. Okay, you might have come across this term silicate structures. There are different types of silicate structures, just like sorosilicate, nesosilicate, inosilicates, single chain inosilicates, double chain inosilicates, phyllosilicate, tectosilicates, right? What are these silicate structures all about? The silicate structures are nothing but the bonding between the silicon and oxygen, right? They bond together to form the silica tetrahedra, like this, right? Like this, or anything like this. There might be any type of bonding, Okay, there might be any kind of sharing, any kind of bonding, and these bonds, okay, these bonds give rise to the minerals, and these minerals are called as silicate minerals. Okay, these minerals are called as silicate minerals. Can you give me an example of silicate mineral? Anybody?
Olivine, pyroxene, amphibole.
It's correct.
Garnet.
Oh, garnet. Right. So majority of the minerals which we observe around ourselves are silicates. Right. Now it is not like there is only silicate magma. Right. There is only silicate magma. There are non-silicate as well. Okay. So there are some examples of non-silicate magmas. Right. For example, carbonatite. Okay. For example, this carbonatite. Now carbonatites, as the name itself indicates, it is rich in carbonate minerals. Okay, it is rich in the carbonate minerals. So majority of the carbonates will be there, but these kind of magmas are rare, right? So on the basis of silica, okay, on the basis of percentage relative amount of silica which is present in a particular rock, the magma and the igneous rock themselves are classified as ultra basic, basic, intermediate, and acidic. Okay, mind you, these terms basic and acidic, right? These terms basic and acidic are based upon the percentage of silica and not on the pH scale. Okay, don't get confused with this pH scale. What is acidic and basic? Don't do that, right? It is strictly on the basis of percent of SiO2, percentage of silica which is present, right? Got this? आगे बढ़े?
Yes, sir.
Sure.
Sir, hello, sir.
Yes.
Please explain this last line. pH, what that pH line?
What? I cannot hear you properly.
Please explain this last line, sir. pH, you told about pH and silica percentage.
See, there is a classification, or there is not this classification. Some liquids, just like water, is called acids and base. Okay, we classify acids and base on the basis of pH, right? On the basis of pH, right? So pH more than 7 acid, less than 7 is base. Correct?
Yes, sir. Right.
So don't get confused.
Okay, sir. Okay.
Okay, so this classification, okay, this classification is based on percent of SiO2. Okay, sure. So this is the classification. Okay, this is the classification for the rocks. Okay, this is the classification of the rock based on the weight percentage of silica. So ultra basic, if it has less than 45% silica. Okay, if it has less than 45% silica, it will be called as ultra basic. It will be called basic. Any rock, any igneous rock will be called basic if it has 45 to 52% of silica, right? 45 to 52% of silica. Any rock will be called intermediate in composition if it has 52 to 66% of silica, and it will be called acidic if it has more than 66% of silica. Okay, this is wet percent of silica which is present in the rock itself, right? Learn these tables. Okay, learn these tables. It will help you in answering the questions. Okay, then There is one more classification on the basis of color of the minerals. Okay, on the basis of color of the minerals. So ultra mafic, then mafic, then intermediate, and then felsic. So ultra mafic minerals are those minerals which have dark or greenish colors. Okay, which are rich in olivine or may also contain pyroxene or amphiboles. Okay, so the rocks, okay, rocks which contain dark color minerals. Okay, the rock which contains dark color mineral, not the dark color rock. So obviously these rocks will become dark colored. Okay, so the rocks which contain dark colored minerals, those will be called as ultra mafic rocks. Mafic rocks, dark colored minerals, also dark color minerals will be there, but not the ultra dark color like this olivine. You might have seen olivine. Okay, you might have seen olivine, not that dark, but less dark than the ultra mafic. Then intermediate, which has grayish to salt and pepper colored rocks. Okay, which are rich in plagioclase, amphibole, biotite. Here, quartz come into picture, right? And felsic. In felsic rocks, we have light colored rocks. Okay, we have these light colored rocks, which are red color or which are rich in potassium feldspar. Okay. So next, the textures of igneous rocks. The textures of igneous rocks. Now, these textures of igneous rocks, which is one of the most important topics in the igneous petrology itself. Okay, so this igneous rocks or the igneous textures, okay, may be broadly categorized on the degree of crystallinity. Okay, it is broadly categorized on the degree of crystallinity. Now, what is this crystallinity? The size of crystal, shape of crystal, right? Mutual arrangement of the crystals, right? All these things are covered into this crystallinity. Okay, all these all these are covered under the crystallinity. Okay, so if there are proper time, then temperature and pressure conditions. Okay, a magma produces crystals. Okay, magma produces crystals. You might be knowing about this, that there are different kinds of crystals, which will actually we are going to see in the course of the lecture. Okay, so with cooling of the magma, okay, with cooling of the magma, say suppose this is a magma chamber. Okay, this is a magma chamber having composition X. Okay, having composition X. Now this magma is cooling down. Okay, this magma is cooling down. While cooling down, what magma actually is? What magma actually is? Magma actually is a chemical fluid. Okay, magma actually is a chemical fluid. Now this chemical fluid contains different kinds of compositions or components. All these components, they are not stable at every temperature, right? At each of the temperature range, they are not stable, right? At different level of temperatures, they will crystallize. Okay, as their cooling or their crystallization temperature reaches. Okay, as the crystallization temperature reaches, they will crystallize. It is evident from the Bowen reaction series, right? It is evident from the Bowen reaction series. Remember the Bowen reaction series, which starts from olivine. Next, what is next?
Pyroxene.
Pyroxene. Next,
Amphibole.
amphibole. Next,
Biotite.
biotite. Next,
Feldspar.
feldspar.
Yes.
Muscovite.
I think Muscovite. Right, Muscovite.
Which muscovite? Then
Feldspar.
Quartz.
Feldspar.
Quartz is the last final stage.
Feldspar.
Right.
Now
So,
feldspar.
okay, this is your Bowen reaction series. Now observe the Bowen reaction series. What it evidence, or what it has the evidence, is that it was the homogeneous magma, right? It was the homogeneous magma, one magma, and from this one magma we have different types of materials, different types of different types of minerals. Okay, from one homogeneous magma, it shows that at particular temperature and particular pressure, only at particular temperature, the particular mineral or particular chemical composition will be separated from the from rest of the magma and from the mineral and from the crystal. This behavior, okay, this behavior of any magma gives rise to the textures. Okay, this behavior gives rise to the texture. Okay, so there might be sudden cooling, or there might be slow cooling, right? There might be extremely slow cooling, there might be extremely sudden chilling. Okay, sudden loss of the gases. Okay, so there are different types of textures which we have to see, right? So these textures or degree of crystallization is classified into three types: holocrystalline first, right? Holocrystalline, hypocrystalline, and holohaline. What is this holocrystalline? Holocrystalline means which is completely crystalline. Okay, holocrystalline is completely crystalline. Completely crystalline means on the surface of the rock or in the rock you will see only the crystals. Okay, you will see only the crystals. Everywhere you will see just the crystals and the well developed, and they will have the well developed crystals like this. You'll have this kind of well developed crystals. Second is the hypocrystalline. Hypocrystalline means which has partially glass and partially crystallinity. Okay, which has partially glass, partially crystallinity, means some amount of crystals will be there and some amount of glass type of appearance will be there, right? And a third category which is called as holohaline. Okay, the third category called as holohaline, and this third category which is completely glass. Okay, which says it is completely a glass. Okay. So these are the three categories. These are the three categories on the basis of which the degree of crystallization has been defined. Okay. Next. So these are the different types of textures which we have to see. Okay. We'll see different types of texture. The first thing is the pegmatitic texture. Okay, the first is pegmatitic textures. Now, what is this pegmatitic texture? Okay, pegmatite basically is a textural term. Okay. Pegmatite is basically a textural term. It is shown by a particular type of rock, right? Particular type of composition, and hence that rock itself is named as pegmatite. Okay, the granitic rock basically. So pegmatitic texture is characterized by larger crystals. Okay, this is important. This is a key term here. Okay, it is characterized by the larger crystals. How much large? More than 30 mm in diameter. Okay, more than 30 mm in diameter. You can see in this picture. Okay, here the picture is given. Okay, in this picture you can see over here. See, individual grains. Okay, these individual grains are larger. Okay, can you see these outlines here, or shall I change the color?
दिख रहा है सर.
दिख रहा है ना? प्रॉपर्ली दिख रहा है कि कलर चेंज करो? बताओ.
दिख रहा है.
Okay, so you can see here, right? You can see here, see these individual crystals See the size. Okay, these are just for the representation purpose. Okay, so see the size of these crystals. Okay, these are larger, or you can even say ultra large. Okay, you can even say this, that these are the ultra large kind of crystals or ultra large kind of grains. Okay. So this pigmented display large early form euhedral crystals surrounded by later form subhedral crystals. Okay. So in naming rock the pigmented texture, as I have told you, the textural term, this term basically, pigmented is basically a textural term. It is a name of a texture and it is not the name of the rock. But we have these the rock. Okay, we have a rock which is granitic in nature, okay, granitic in composition, and it shows the pigmented texture. Okay. It shows pigmented texture, and hence that rock itself is called as a pigmatite. Okay, so the pigmented textures develop most commonly in granitic plutons. Okay, they develop most commonly in the granitic plutons. Okay, gabbroic plutons rarely display any pigmented textures. Okay, because they have the lower volatile gas content. Okay, and these pigmatites, okay, pigmatites have well developed crystal forms, and they are the source of many gemstones such as sapphire and topaz. Okay, nowadays, or these REEs, they are generally these REEs are generally searched in the pigmatites, right?
Sir, these individual crystals are the particular mineral present ना?
क्या क्या?
मतलब जितने भी इंडिविजुअल क्रिस्टल्स है ये एक
हाँ
पर्टिकुलर मिनरल को शो करते हैं ना, ऐसे
हाँ
नहीं
हाँ
व्हाटएवर द मिनरल प्रेजेंट ना.
हाँ, whichever the mineral is present. ठीक है. Next, next is the phaneritic textures. Okay, next is the phaneritic textures. These phaneritic textures are finer than that of the pigmatic textures. Okay, pigmatic texture से थोड़ा सा grain size इसमें छोटा हो जाएगा. ठीक है, pigmatic texture से grain size छोटा हो जाएगा. ठीक. So this phaneritic textures is implies the crystal diameters ranging from 1 to 30 mm. Right, it shows the diameter ranging from 1 to 30 mm. That means you can distinguish individual grain with naked eye. Right, you can distinguish the particular grain with naked eye, so visible to the naked eye. ठीक है. So आप ऐसे ही किसी रॉक को हाथ में लेके प्रॉपरली उसे देख के आप उसको बता सकते हैं. इंडिविजुअल ग्रेन यू कैन पॉइंट आउट. राइट. So here, early formed crystals are euhedral, later formed crystals are subhedral to anhedral. Okay, I hope you know these terms: euhedral, subhedral, and anhedral. Do you know these terms, or shall I revise it? Yes. Everybody?
Revise it, sir.
Everybody is familiar with these terms, or do you need a revision? Okay. So I suppose as today's class, Sonal is highly active and sometimes Ujjwal. Rest others, are you there or just meeting चालू करके भग गए?
Sir, not required revision. Continue,
Okay.
sir.
Okay. Shraddha Nimbarti is there, right? She is attentive. Know this. Okay. Chalo. So I'm glad to know that you know this. So early form crystals are euhedral and the later form crystals are subhedral to anhedral. Right. Now this phaneritic textures may be subdivided. Okay. This phaneritic texture may be subdivided into fine, which is 1 to 3 mm in diameter. Okay, finer grain, medium grain, or coarse grain textures. Okay, in your practicals of igneous petrology, you might have written all these things. Okay, in your practicals, you must have written all these things. Okay, coarse grain, medium grain, fine grain on just the visual interpretations. Okay, on just the visual interpretation, or you might have taken the aid of the hand lens or the pocket lens, right? So, finer grain phaneritic textures, they commonly develop in the shallow plutonic structures such as dikes and sills. Okay, in sills and dikes, you may encounter with the finer grain phaneritic textures. Finer grains are observed in dikes and sills. Coarser grains are generally associated with larger or deeper intrusions. That is, generally, these coarser grained rocks are plutonic, right? The coarser grained rocks are generally plutonic. Okay, so rock names such as granite, diorite, and gabbro, okay, they have phaneritic textures. Okay, they have phaneritic textures. So pigmented की तरह इसमें phaneritic granite, phaneritic gabbro, you don't need to address the rocks like this. Okay, don't need to address the rocks like this. You will just say granite, just say gabbro, just say this diorite, whatever the rock is. Okay, whatever the rock is.
सर ये कोर्स ग्रेन का बताइए ना. डीपर इंट्रूजन मींस क्या मानेंगे इसमें?
डीपर इंट्रूजन मींस जो प्लूटोनिक डेप्थ पे बनने वाले रॉक्स है. ठीक है, जो प्लूटोनिक डेप्थ पे बनने वाले रॉक 3 टाइप के होते हैं. ठीक है, एक होता है प्लूटोनिक, दूसरा होता है वोल्केनिक, तीसरा होता है हेपाबिसल. राइट, इट इज ऑन द बेसिस ऑफ plutonic, volcanic, and hypabyssal. Right? These are the 3 types of rocks. Okay? These are deep seated. ठीक है, और ये कहाँ बनते हैं? सरफेस ऑफ अर्थ. ठीक है, और ये बनते हैं इंटरमीडिएट डेप्थ पे. ठीक है, ये बनेंगे आपकी इंटरमीडिएट डेप्थ पे. सो these rocks, deep seated rocks, when they come on the surface, right, these plutonic rocks or this deep seated rock, when they come on the surface, they come as the intrusions, right? They come on the intrusions. These are called deeper intrusions. ठीक है, समझे क्या सोनल?
बैथोलिट में मान सकते हैं क्या इसको?
क्या
बैथोलिट में मान सकते हैं क्या डीपर इंट्रूजन?
अगर उतने बड़े डायमेंशन का हुआ तो बैथोलिट भी हो सकता है. अगर वो बैथोलिट की डेफिनेशन में बैठ रहा है तो उसको हम बैथोलिट बोल सकते हैं. ठीक है, बैथोलिट की डेफिनेशन मतलब क्या? विच शुड कवर द एरिया ऑफ 100 स्क्वायर किलोमीटर. ठीक है, मोर देन 100 स्क्वायर किलोमीटर, इतना बड़ा एरिया होना चाहिए. उससे थोड़ा सा कम भी रहा, 99 स्क्वायर किलोमीटर का एरिया रहा, तो हम उसको स्टॉक बोलेंगे. राइट, उसको हम स्टॉक बोलेंगे, उसको बैथोलिट नहीं बोलेंगे. ठीक है, सो अगर उतने बड़े डायमेंशन पे आ रहा है, देन इट विल बी कॉल्ड एज बैथोलिट. ओके.
Hello, sir.
Yes.
Sir, are deep-seated rocks are highly viscous?
What? I cannot hear you.
Sir, deep-seated rocks highly viscous है क्या sir?
Deep-seated rocks are highly viscous. See, viscosity of the rock is dependent on the silica content. Right? It does not have anything to do with the depth. Okay. It has everything to do with the silica content. More the silica content, more will be the viscosity. Less the silica content, lesser will be the viscosity. Okay.
Okay, sir. Okay, got you.
Next, aphanetic textures. Okay, aphanetic textures. Now, aphanetic texture is the texture which is even lesser than that of the phaneretic. Which is even lesser than that of the phaneretic. So it has the grain size. Okay, it has a grain size of less than 1 mm. Okay, less than 1 mm in diameter, and these grains are not visible to the eye. Discernible. Okay, these are not visible, or these are not distinguishable by the naked eye. You cannot distinguish individual grains. Okay, you will see that there are grains. Okay, there are grains which are present on the rock itself, but you cannot distinguish between the individual grains from the rock or the rock surface. Okay, so what you will need a high power lens. Okay, which has larger magnifications. High power lens which has higher magnifications, or you need to go for the microscope. Okay, you need to go for the microscope if you want to have a deeper analysis of the rock. Okay, if you want to see the texture of such rocks, the aphanetic texture. Okay, if you want to see the textures of the aphanetic rocks, or aphanetic texture for that matter, what you have to do, you have to prepare the slide. Okay, you have to prepare the slide and then go for the microscopic method. Okay, go for the microscopic method, and then you can observe the crystals there. Okay, you can observe the crystals. So aphanetic rocks, these aphanetic rocks are associated with volcanic rocks. Okay, they are associated with volcanic rocks. Now just tell me one thing. Have you ever burned the glass? कभी ग्लास को जलाया है? ग्लास मतलब कांच का टुकड़ा. ठीक है, आपके बीएससी में या 12th में भी इवन एक एक्सपेरिमेंट हुआ करता होगा. ओके, एक एक्सपेरिमेंट हुआ करता था जो उसमें एक क्या बोलते हैं उसको, एक फ्लास्क होता है, एंड you have to burn or you have to heat it till it becomes red hot. याद आ रहा है ऐसा कुछ एक्सपेरिमेंट हमने किया था किसी जमाने में? नहीं यार, भूल गए. चलो, सुना मैंने तो किया था. Okay, so making the glass red hot. Okay, making the glass red hot. ठीक है, and if you go for sudden chilling, उसको बर्फ में डाल दो, क्या होगा? किसी चीज को बहुत गर्म किया, ठीक है, बहुत गर्म किया, और बहुत गर्म करने के बाद उसको डायरेक्टली बर्फ में डाल दिया, सडनली चिल कर दिया, व्हाट विल हैपन? जस्ट नॉर्मल फिनोमेनन.
सॉलिड हो जाएंगे सर.
व्हाट विल हैपन?
सॉलिड हो जाएंगे डायरेक्टली.
क्या होगा? मुझे
सॉलिड होगा सर, एकदम
सॉलिड होगा.
हाँ,
क्रैक डेवलप होंगे.
क्रैक्स डेवलप होंगे. इट विल क्रैक, इट विल शैटर. ओके, इट विल शैटर. करके देख लो. आपके घर पे अगर कोई ग्लास होगा, मतलब जो ऑब्वियसली नया नहीं, पुराना वाला कोई पड़ा हुआ, तो उसको अच्छी तरह से गर्म करो, पूरा लाल लाल, और उसको डायरेक्टली एकदम बर्फ में डाल दो, टुकड़े टुकड़े हो जाएगा. ठीक है, टुकड़े टुकड़े हो जाएगा. व्हाई इज इट सो? व्हाई इट हैज शैटर्ड? ओके, व्हाई इट हैज शैटर्ड? बिकॉज इट हैज cooled quickly. Because of this quick cooling. Okay, because of the quick cooling. As the cooling is very quick, okay, as the cooling is very quick, in terms of magma I'm talking about, if the cooling is very much quick, it does not get enough time to develop the crystal. Okay, no time to develop the crystal. Okay, it does not get any it hardly gets the time to develop the crystals or well-developed crystal to link the Si and O tetrahedra, okay, properly, obviously, okay, and it does not get that much amount of time to create larger crystals, to develop larger crystals, and hence it suddenly cools. Okay, it suddenly cools, and this sudden cooling, okay, this sudden cooling gives rise to this auphanetic texture. Okay, this sudden cooling gives rise to this auphanetic texture. Okay, now this auphanetic texture may be subdivided into the microcrystalline and cryptocrystalline. अब इसमें भी दो varieties आती हैं, ठीक है, इसमें भी दो varieties आती हैं, ठीक, एक होता है microcrystalline, okay, and another one is the cryptocrystalline. Okay, microcrystalline and cryptocrystalline. Now, what is this microcrystalline? Microcrystalline textures, they contain microlite crystals. Okay, they are microlite crystals, means crystals which are larger enough, okay, which are larger enough to be identified by a petrological microscope. That means you can create a slide, you can make a slide of these rocks, okay, these microcrystalline rocks, observe it in the petrological microscope, right, observe the petrological microscope, and you can see the different grains. Okay, you can see the different grains, or the texture is visible inside the metrological microscope. But in case when the crystal size is too fine, okay, when the crystal size is too fine to be identified even with a metrological microscope, what do you need for this? You need even higher resolution. Okay, even higher resolution, just like electron microscopes. Okay, these kind of crystals or these kind of rocks are called as cryptocrystalline. Okay, these are called as cryptocrystalline. That means it is completely completely like glass or completely powdered form. Okay, if you powder it and take it into your hand, you will feel it like the powders. Okay, so it is cryptocrystalline, ultra fine. You can name this as ultra fine. Okay, this is ultra fine type of crystal. Next, now this is the most famous one when we are talking about the textures. Okay, when we are talking about the textures, porphyritic texture. Okay, the famous texture, porphyritic. What is porphyritic texture? You might have seen porphyritic textures. Okay, it contains two distinctly different size crystals. Okay, distinctly two different size crystals. That means larger crystals are embedded into the finer crystals or the ground mass. Say suppose this is a larger crystal. Okay, this is a crystal, or this entire is a rock, and this is ground mass. Right, these larger crystals, okay, these larger crystals are called as phenocrysts. Okay, the larger crystals are called as phenocryst, and this is called as ground mass. Okay, the finer material is called as ground mass, and the larger crystals are called as phenocrysts. Right. So porphyritic, all the crystals are visible to the eye. Porphyritic, phaneritic textures, all the crystals are visible to the eye. You can see the rock, you can observe the texture. Okay, you can observe the texture in the hand specimen itself. Okay, the hand specimen itself. But porphyritic or phanetic textures, there are some aphanetic textures which has larger phenocryst are embedded in an aphanetic ground mass, right? Which is largely composed of microcrystalline or cryptocrystalline or glassy material. Okay, so these materials are dominant here. Okay, these materials become dominant, and hence you cannot see the actual porphyritic texture in the aphanitic rocks, right? So if present, you can see this this rock, okay, porphyritic texture in aphanitic rocks into the microscope. Okay. Next is the glassy texture. Okay, next is the glassy texture. Okay, the rocks such as obsidian, okay, such as obsidian, glassy texture, there is no crystal at all. Okay, you cannot see the crystals, no crystals at all, completely glass. Okay, what you will observe is completely a glass. Okay, that means they have majority of the cryptocrystalline material. Okay, they have majority of the cryptocrystalline material. Now how these this kind of rocks are developed? Okay, these kind of rocks are developed when the glasses are essentially super cooled liquids. Okay, these are essentially the super cooled liquids, they are suddenly chilled. Okay, they are suddenly chilled generally when the magma erupts inside the water. Okay, inside the water. So there are two mechanisms. Okay, there are two major mechanisms which are called as quenching and rapid gas loss. Okay, quenching and rapid gas loss. What does it mean, quenching? Quenching का meaning क्या होता है?
Sudden cooling.
Quenching means sudden chilling or sudden cooling. Okay, just like I am quenching my thirst, right? So quenching means basically suddenly getting cooled. Okay, and rapid loss of the gases. So whatever the gases are there, okay, whatever the gases are there, they are getting lost. Okay, the gases are getting lost, and the material is getting segregated to form the rock or to form the glass basically. Okay, so this will be called as the glassy texture. You will observe the glass only and no crystals at all. Okay, no crystals at all on the surface of this rock or in the rock itself. Okay, next is the vesicular texture. Okay, vesicular texture, or this is also called as vesicular structure. Okay, this is also called as vesicular structure or vesicular texture. What is this vesicular texture? What is vesicle basically? What basically is a vesicle?
Small pores.
Small
Holes.
pores, correct. Formed due to
Gas exim.
Gas.
formed due to loss of gases, right, during
Loss of
cooling
gas.
of the magma. Okay, during cooling of the magma. Now when the magma comes out on the surface, okay, magma comes out on the surface and flows. Okay, flows, it has a lot of amount of the trapped gases. Okay, a lot of amount of the trapped gases. These trapped gases, they try to escape. Okay, they try to escape whatever, wherever they get the suitable location, they get escaped from the magma. Okay, they get escaped from the magma. Now during this escape they leave behind the spots from where the gases have been escaped. Okay, and these are nothing but the cavities. Okay, these are nothing but the cavities, and these cavities are in turn are called as vesicles. Okay, these cavities are called as vesicles, and a rock which contains such vesicles will be called as vesicular rock. Okay, the rock which contains such vesicles will be, is called as vesicular rock. Just a minute. Okay. Now, sometimes it occurs that these vesicles are filled by a secondary material. Okay. This is filled by a secondary material. Say suppose this whatever I am drawing with blue is a secondary material which is getting filled after the formation of the vesicles. Okay, this kind of secondary material, these kind of vesicles which is filled by a secondary material, they are called as amygdals. Okay, they are called as amygdals, and the rock will be called as amygdaloidal. Okay, the rock will be called as amygdaloidal. Okay, so the secondary materials, amygdals, are secondary materials. Especially, you can see this, or you can observe this phenomenon in the basaltic rocks. Okay, the basaltic rocks. If you see the basalts or the Deccan basalts, you will find these amygdals. Okay, these amygdals, the zeolites mineral. Okay, this mineral zeolite is present in the vesicles as the amygdala. Okay. Next, the pyroclastic textures. Okay, the pyroclastic textures. What is this pyroclastic material? What is the
Derived
pyroclastic
from
material?
volcano.
A solid material which is coming out of the volcano, right? Solid material which is coming out of the volcano. Eject broken rock particles of varying sizes known as pyroclasts. Okay, these are called as pyroclasts or pyroclastic materials. Okay. Now, these pyroclastic materials, they come on the surface. Okay, they come out on the surface and they form a rock. Okay, they will form a rock here on the surface. Such rocks will have some of the textures that will be called as pyroclastic textures. Okay, that means first there will be volcanic eruption. Okay, volcanic eruption, and through this volcanic eruption, some solids will be thrown out. These solids will stack one over other. Okay, these solids will stack one over other. There might be dust, there might be bombs, there might be lapilli. Okay, these this will get stuck, and these will be welded and cemented. Okay, these particles will be cemented or welded together. Okay, welded together to form a rock. Okay, to form a rock. Such rock will possess a pyroclastic texture. Okay, it will possess the pyroclastic texture. Okay. Now, pyroclasts are classified according to their composition. Okay. These pyroclasts are classified according to their compositions. Okay, so there are three types: lithic pyroclasts. Okay, lithic pyroclasts which have basalts, andesites, and some other rock, the fragments obviously. Okay, the fragments of basalts, then andesites, then or any other rocks. Then vitric pyroclasts, which contains the glassy fragments. Okay, which contains the glassy fragments, most commonly pumice and scoria. Okay, and crystals, which contains the minerals, the mineral crystals. Okay, you might be aware of this pumice or scoria and the rocks, right? Pumice rock and scoria rocks. Okay, you might be aware of these rocks. Okay, they're formed with the frothy material. Okay. देखा है क्या प्यूमिस और स्कोरिया?
Yes,
प्यूमिस
sir.
देखा है सबने?
Yes, sir. Yes, sir.
प्यूमिस देखा है? आप लोगों के बाथरूम्स में होंगे, ठीक है? एक टाइप का रॉक होता है जिसको नहाने में यूज करते हैं, ठीक है, आपकी बॉडी को रब करने के लिए.
यस सर, देखा है।
हाँ, so that is pubis. That is nothing but a volcanic rock which is vitric pyroclast. ठीक है. Okay, so here you can see the classification. Okay, this is the IUGS classification of pyroclastic debris. Okay, pyroclastic debris. Pyroclastic debris means whatever the materials are coming out of the volcano. Okay, whatever the materials are coming out of the volcano, they are classified on the basis of their sizes. Okay, the basis of their size. So the largest ones are called as blocks and bombs. Okay, the largest ones are called as blocks and bombs, which have the diameter of more than 64 mm. Okay, which have the diameter of 64 mm. And the materials, okay, the material, the rock which is formed, okay, the rock which is formed due to these blocks and bombs, they are called as pyroclastic breccia if it is formed due to blocks, and it is called agglomerate if it is formed due to the bombs. Now, what is the basic difference between blocks and bombs? There is a basic difference between blocks and bomb is their angularity. Okay, is their angularity. If it is angular, it will be called as block. Okay, if it is angular, it will be called as block. If it is circular, or obviously it won't be a circular. Okay, it will have smoother edges. Okay, it will have smooth edges. Then it will be called as bomb. Okay, if it has angular edges, it will be called as block. If it has circular edges, it will be called as bomb. Okay. Next is the lapilli. Okay, 2 to 64 mm in the diameter. Okay, a material which has 2 to 64 mm in diameter. Rock formed due to such material is called as lapilli stone. Okay, then ash, which is less than 2 mm in diameter. Okay, 2 mm in diameter. Rock formed due to ash will be called as tuff or ash tuff. Okay, the rock which is intermediate between lapilli and ash is lapilli tuff, which is the amalgamation of both the materials. Okay, this is the amalgamation of both the materials, and here, which is actually intermediate rock between block and lapilli and ash, is called as tuff breccia. Okay, it is called as tuff breccia. So you can remember this diagram.
सर ये ब्रेशिया में भी एंगुलर ग्रेन्स रहेंगे
क्या?
ब्रेशिया में भी एंगुलरिटी डेवलप रहेंगी?
हाँ, एंगुलर फ्रैगमेंट से बना है, इसीलिए उसको ब्रेशिया बोलते हैं. ठीक है, एंगुलर फ्रैगमेंट.
सर एक और टर्म आता है लाहर करके. सर लाहर में भी पायरोक्लास्टिक मटेरियल्स ही रहते हैं क्या?
लाहर में भी पायरोक्लास्टिक मटेरियल्स ही रहते हैं, बट लाहर व्हेन इट इज मिक्स्ड विद वाटर एंड द फ्लोज, वो जो स्लरी होती है, वो स्लरी फ्लो करना चालू करती है. मड एक्चुअली, उसको ग्लोइंग मड बोलते हैं.
यस सर, आई नो.
ठीक है, सो वोल्केनो से जो मड निकलता है, जो बहुत ज्यादा गर्म होता है, ठीक है, उसको बोलते हैं लहर.
सर टब ब्रेशिया भी कंपोजिशन
क्या?
टब ब्रेशिया में
हाँ,
ये जो तीनों भी कंपोजिशन कुछ रहेंगे उसमें सर?
हाँ, तीनों का इंटरमीडिएट कंपोजिशन रहेगा उसमें.
और सर ये लैपिलिस स्टोन एसिडिक है कि सर बेसिक? ये नया वर्ड है, मैं सुना नहीं सर. लैपिलिस स्टोन,
lapilli stone means which stone which or a rock which is formed due to lapilli. That's it.
सर मतलब इसमें सिलिका मतलब ये एसिडिक रहेगा कि बेसिक रहेगा ये लैपिलिस स्टोन?
ऐसा कुछ नहीं है, इसमें वो कंपोजिशन नहीं आता. There can be anything. These rocks, see, these rocks and these kind of this classification is irrespective of composition. Okay, this is irrespective of composition. This is strictly based upon these sizes. Okay, it is based upon these sizes. अगर इन sizes के पैरामीटर्स में वो बैठ रहा है तो उसको वो बोलेंगे. ठीक है, अगर 2 से 64 mm में बैठ रहा है तो लैपिली बोलेंगे. देन it may be irrespective, it may be acidic, it may be basic, right? It may be a part of granite, it may be a part of basalt, it may be a part of gabbro, it may be part of granodiorite, it may be part of komatiite, for that matter. ठीक है? और extreme level इक्लोगाइट का भी पोर्शन आ गया उसमें, ठीक है? इक्लोगाइट तक का पोर्शन आ गया, but what we are getting is this size range. Okay, what we are getting is this size range. Then for us it is lapilli. Okay, क्योंकि वो वोल्केनो से निकला है, क्योंकि वोल्केनो से निकला है और उसी साइज के ढेर सारे मटेरियल से मिलके एक रॉक बना है, तो उसको हम लैपिली स्टोन बोलते हैं. ठीक है, उसका कंपोजिशन तो बाद में देखेंगे.
ओके सर,
समझे
सर?
See, this is what I was talking about. Okay, whatever is given in the previous diagram is now explained here in this chart. Okay, more than 64 angular block. If angular block, it will be Brexia. Okay, angular block. Okay, it will be a block. Right. Then 2 to 64 lapilli. ठीक है, here it will be ash, fine ash. तो थोड़ा सा ज्यादा उसको रिफाइन किया, बाकी कुछ. ठीक. Next is the color index. Okay, you might have written this color index, leucocratic, melanocratic, लिखा ये सब. ठीक है, ये सब आप लोगों ने लिखा होगा. ठीक. So what is this color index? Color index is also called as mafic index. Okay, the color index is also called as the mafic index. So it is the proportion of mafic minerals. Okay, proportion of mafic minerals, the proportion of mafic minerals in the total population of filsic and mafic minerals. ठीक है, so इसका फॉर्मूला क्या होगा?
मैफिक अपॉन
color index,
मैफिक अपॉन फेल्सिक प्लस मैफिक,
percent of mafic minerals upon percent of mafic plus
फेल्सिक.
percent of filsic. ठीक है, so how will you calculate the color index? Color index will be calculated by this formula: percent of mafic minerals upon percent of mafic plus percent of filsic minerals. Okay, which is present in the rock itself. Okay, so this color index classification is based upon the proportion of light and dark colored crystalline minerals. Okay, crystalline minerals, whatever the crystals are present. Okay, whatever the crystals are present in that rock, this is the only decisive factor and does not consider the dark colored non-crystalline solids. Okay, whatever the non-crystalline solids are present, they are not considered. Okay, the colored the dark classes are not covered, just the crystals are covered here. Okay, so these igneous rocks can be subdivided into 3 to 4 groups. ठीक है, कौन से felsic, intermediate, mafic and ultramafic. ठीक है, felsic, intermediate, mafic, ultramafic. felsic less than 40% DCM. What is DCM? Dark colored minerals. Okay, less than 40% of dark colored minerals. A rock which has less than 40% of dark colored minerals will be called as felsic. Okay, intermediate, which has 40 to 70% DCM, mafic, which has 70 to 90% DCM, and ultramafic, more than 90% DCM. Okay, more than 90% of DCM. Okay, so IUGS has developed a color index scheme. IUGS has developed a color index scheme for the for this kind of rocks. कौन सी? Leucocratic, mesocratic and melanocratic. Okay, leucocratic, mesocratic, melanocratic. Now this leucocratic rocks contain 0 to 35% of DCM. Okay, leucocratic rocks contains 0 to 35% of DCM. Mesocratic rocks contain 35 to 65% of DCM, and melanocratic rocks contain 65 to 100% of DCM. Okay, dark colored minerals. Okay, so there might be relative proportion of felsic minerals. Okay, there might be felsic rocks, intermediate rocks. On the basis of that, we have devised these three terms: leucocratic, mesocratic, and melanocratic. Right? For this,
Yes, sir.
see, everything which I had written in the last slide is given in one table. You can remember this one table and your work will be done. Okay. Now, coming to the IUGS classification. Okay, this is IUGS classification. IUGS means International Union of Geological Sciences, and this IUGS classification has classified the igneous rocks. Okay, IUGS has classified the igneous rocks on the basis of modal concentrations. Okay. Modal concentration. What is this modal concentration? Modal concentration means relative concentration of particular mineral. Okay, a relative concentration of particular mineral. So on the basis of 5 essential mineral groups, these are called as Q, A, P, F, and M. Okay, Q, A, P, F, and M. So in the diagrams, we'll have these 4 parameters: Q, A, P, and F. So you might have learned about such diagrams. Okay, ये ऐसी कुछ diagrams के बारे में आपने पढ़ा होगा. ठीक है. So these diagrams are called as IUGS classification. Okay, or QAPF classification. So in this, Q represents quartz, tridymite, cristobalite. Okay, it represents quartz, tridymite, and cristobalite. A for alkali feldspar, right? A represents alkali feldspar. So alkali feldspar including orthoclase, microclane, sanidine, perthite, anorthoclase, albite, everything, right? P represents plagioclase, okay, plagioclase and scapulite. Then F for feldspathoid, which are written as foids, okay, which are written as foids. The term this feldspathoid rich, okay, feldspathoid rich, so foid. Okay, so it includes nepheline, sodalite, cancrinite, leucite, analcite, Nocian, Hoin, calcite, everything. All these feldspathoids. Okay, so you must know about these feldspathoids. And M is mafic and related minerals. Whatever minerals which are not felsic, which are not covered in the Q, A, P, and F. All this, including olivine, pyroxene, amphibole, mica, melilite, garnet, epidote, calcite, all the minerals. Okay, these are covered, or these are covered under the heading of M. Right. Now see these diagrams. There are 4-5 such diagrams. There are 4-5 such diagrams. So in these diagrams, what you have to do, you have to just draw the diagram in your copy and practice it to draw. Okay. Nobody is going to ask you to draw the diagram, but they will ask you about the individual field and their individual field and its component. Okay, just like they might ask you about, by giving the diagram, the blank diagram, and here in the place of quartz monzonite there will be a question mark. Okay, there will be a question mark and you need to give the answer. Okay, what lies in that field? Okay, what lies in that field? So you need to identify such rocks from here. So in this rock, 35 rocks are 35 rocks are given. Okay, so this classification, okay, this classification is for plutonic rocks. Okay, this classification is for plutonic rocks. Okay, you can see it's granodiorite is there, tonalite, monzodiorite, okay, diorite, gabbro, granite is present here. Okay, so what you have to do, you have to learn the diagram thoroughly. Okay, all these diagrams, just practice it 4-5 times. Okay, practice the diagram 4-5 times and you will automatically learn the diagram. Okay. Next, this is the gabbroic rock composition or the gabbroic rock classification in the same fashion. Okay, in the same fashion here the apices are different. Okay, the apices are different here, the plagioclase, then pyroxene, then olivine. Okay, the minerals are different here. Okay, minerals are different than that of the previous diagram. Okay. So they have given you this kind of classification. So here 90% plagioclase will be called as anorthosite. Okay, here this field represents gabbronorite or norite. This field represents pyroxene bearing ultramafic rocks. Okay, these are called as gabbroids completely. Okay, here in this field you will have troctolite, and such rocks are present. Okay. These are the gabbroic rocks. These are these gabbroic rocks. Again, practice this diagram. Okay, practice the diagram. You will have to learn the diagrams. Same, it is ultramafic plutonic rocks. Okay, these are the ultramafic plutonic rocks. Right, you can see here dunite is there, then harzbergite, olivine orthopyroxenite, since here the orthopyroxene apex is there. Here CPX, clinopyroxene apex is there, and here there is olivine. Okay, so these are the ultramafic rocks. Ultramafic rocks means which have larger amount of dark colored minerals. Okay, large amount of dark colored minerals. Okay, so this entire field is for peridotite, and this entire field is for pyroxenite. Okay, relative percentage of all these minerals. Okay, the relative percentage of all these minerals have given rise this kind of fields. So this entire field is for verlite, this entire field is for olivine clinopyroxenite, this field is for harzbergite. Okay, this will be for Websterite. This is the classification. Same classification or the same scheme is employed in the next diagram itself. Here just the apices are changed: olivine, pyroxene, and hornblende. Right, olivine, pyroxene, and hornblende. Here both the pyroxenes were used, orthopyroxene as well as clinopyroxene. But in the latter diagram, the diagram B, you have pyroxenes at one apex and hornblende at another apex. Okay, so the name of the rocks change. Okay, the names of the rocks change. So pay attention to the names of the rocks and apices as well. Pay the attention to the apices. Do not just in hurry. Don't just take any random option. Right. Now this is volcanic rock classification. As we have seen the plutonic rock classification. Okay, the classification of plutonic rocks. Same way we have the volcanic rock classification as well. Okay, so this is the volcanic rock classification. All the rocks which are present in this diagram are the volcanic rocks. Okay, so here you will see rhyolite, dacite, then andesite, basalt andesite, right? And trachyte. You can see, or you can comparatively study plutonic and volcanic rocks. Okay, the study of the diagrams, IUGS diagrams or QOPF diagram of volcanic as well as plutonic rocks simultaneously, side by side, or what can I say? The comparative study of both these kind of diagrams. Okay, to the comparative study of this, you will come to know one more exciting thing, which is the equivalence. Right, which is the equivalence. Observe this. The same field which is occupied here by the rhyolite was occupied in the plutonic rocks by granite. Right, the same field was occupied in the plutonic rocks by the granite. Right, so same way you can do the comparative study of these two diagrams. Okay, these two diagrams will give you the insight of the equivalents, the plutonic and volcanic equivalents of each other. Okay, which is again used for the questions. Okay, so this is all about the classification of igneous rocks. Okay, this is the classification of igneous rocks which we had to study. I hope you understood the classification of igneous rocks.
Yes, sir.
Have you understood this entire thing, entire topic?
Yes, sir.
Okay. If you have anything in mind, if you want to ask anything, the forum is open for you.
सर ते जे क्वार्ट्स मिनरल्स